Hi and hello, welcome to Saraswat classes. This is Dr. Ruth Sarkar over here, and the reaction that we are going to discuss today is the Prevost reaction. Basically, an oxidation reaction used to convert the alkenes to trans-diols. What is the reagent over here? So we have taken styrene and we are using silver benzoate in presence of iodine. Solvent is your dry benzene. This will lead to the formation of a dibenzoate ester, which we will be showing in the mechanism section. Upon hydrolysis, it gives the 1,2-diol. And to be precise, this is a two-step transformation of an olefin to 1,2 trans-diols and known as Prevost reaction. Important facts about the reaction applicable for cyclic and acyclic alkenes. The initial products are diastereomeric trans 1,2-dicarboxylates, which when hydrolyzed under basic conditions gives you trans 1,2-diols, that is the anti-products. In rigid cyclic systems also the reaction is highly diastereoselective, means leads to the formation of trans diols. The most commonly used reagent is silver benzoate, but one can also use thallium acetate or other silver carboxylates. When there is a conjugated and isolated double bond, which one will be getting oxidized? The dihydroxylation usually will take place at the isolated double bond. So another observation by Woodward, using the same reagent, but one modification was the use of the wet acetic acid, and here a different result was obtained, which again we will be explaining how this happens mechanistically, and it leads to the formation of the cis diols. So Prevost trans-diols, Woodward cis diols. Now both Prevost and Woodward methods can be carried out in high yields using thallium acetate or thallium benzoate instead of using a much more costlier silver carboxylate. Well, the scheme and for the reaction over here is, let's take an alkene where all the alkyl groups 1, 2, 3, 4 are different, and as you can see we're using a inert solvent such as benzene, leads to the formation of trans dicarboxylates, and two such can be formed in the mixture. And once you're using a basic base to cleave off the carboxylates to form the sodium salt of the acid and over here the alcohol, so you are getting the mixture of trans 1,2-diols over here. In the Woodward Butcher modification, the difference over here is that we are using either water uh, in presence of acetic acid, and say one equivalent has been used. Over here the solvent was inert, here it is not inert, and so for that what happens is it leads to the formation of a cis orthoacetate type of a cyclic molecule, which undergoes base hydrolysis and gives the formation of the cis diol. Let's look at a few examples. Okay, the first, the mechanism. So out here we can see that there is a electrophilic addition of the iodine to the alkene, leading to the formation of the iodinium ion. In medium we are having the silver carboxylate, which will make a nucleophilic attack, and for that the iodinium ion will open up. Again, one can think a NGP type of attack from the carboxylate taking place and displacing the other iodine, leading to the formation of a 1,3 dioxolanium ion, and this, when it is further attacked by the carboxylate ion of the silver or silver carboxylate ion, and this would be meaning that this is a SN2 type of attack and leads to the formation of the trans 1,2 dicarboxylate, Basic hydrolysis will have no effect on the stereochemistry at these points, but just leave, it will be cleaving these bonds over here, that the CO bonds over here and here, and that would mean it will lead to the formation of the trans 1,2 diol. So this is a rigid ring and we are using the Prevost condition, and as we have said before, the product over here is going to be leading to the formation of the trans dicarboxylate. We said it was going to be diastereoselective, if you remember the points that we had discussed before. And once you are doing the basic workup, so it will lead to the mixture of these trans diols. Okay. Next, we are having trans-butene, and since the addition over here is going to be anti-addition, okay, so one can think of the formation of the 1,2 diol, which will be having the meso stereochemistry. Next, if you're using the cis-2-butene, obviously the product over here is going to be a DL pair of the 1,2 trans dicarboxylate, which on further nucleophilic attack by the base over here at these esters will lead to the formation of the trans 1,2 diol. Okay. Next, we can see that there are so many conjugated double bonds over here, and as we had proposed that under the previous condition, the isolated double bond will be undergoing electrophilic addition reaction, leading to the formation of the 1,2 dicarboxylate, which when treated with further, if you treat this molecule with the OH group, it will lead to the formation of the 1,2 trans diol. Let's look at the Woodward-Butcher modification. So this was the intermediate that was formed, and if you just go back and compare, out here in the previous condition, the other molecule of the silver carboxylate, the carboxylate ion is going to make a SN2 attack over here, and so it leads to the formation of the trans 1,2 dicarboxylate, and that would undergo basic hydrolysis to give the product. But out here in the Woodward condition, the water is making a nucleophilic attack. Water is no longer an inert solvent, and for this what happens, a cis ortho carboxylate is being formed, which under the conditions of basic hydrolysis will lead to the formation of this product, which further undergoes ester hydrolysis to give the product of cis 1,2 diol. Okay, so that was the discussion on the name reaction of Prevost and Woodward. Thanks for listening. Keep visiting Sarasa classes for other oxidation reactions for the exam of CSR NET, GATE, JAM. Here is Dr. Sarkar saying goodbye. Thank you.